Welcome back. We're going to do chapter 20 now. This is the urinary system. And this doesn't seem like, the urinary system doesn't seem like it would be quite as critical as maybe, you know, the respiratory system or the cardiac system or you know, a lot of the other systems. But the urinary system actually is critical for for human anatomy. And the urinary system is so critical because it deals with liquids, it deals with excretions, but it deals with waste. And a lot of waste are so toxic to the human body. And, you know, it's incredible what we put into our body. You know, even if it's, you know, I mean, some people put smoke in their body, some people put alcohol in their body, some people put poisons in their body, some people breathe in, you know, all kinds of stuff. But even though we don't realize we put toxic stuff in our body, we put preservatives in there that we eat every day. We take medicines that have to be broken down in the body and remove the waste. The reason why they're not all poisonous is because the body can get rid of them. It's kind of like the Food and Drug Administration says we're allowed to have so many parts per million. Okay, like for example, in this area of Texas and New Mexico and other areas in the United States, there's actually there's a small amount of arsenic in your drinking water. Well, what's arsenic? Arsenic is same thing we put in rat poisoning, but you know, if you can have so many parts per million, okay, meaning if you have 1 million liters of water, you could have you know, you could have 10 milliliters that could be arsenic. So it's a really small amount. But what determines that is how much the body can filter off. So we're going to start talking about the kidneys first of all. There's a lot to the urinary system, but the kidneys are vital. Anytime you hear the word renal or the renal system, it involves kidneys. As a matter of fact, renal is, and we're not going to get into the Latin and different things, but anytime you hear the word renal, think kidneys. All right. Now, I want to pull this directly out of your book because there's a couple of things here, and you've already read these, you've already worked on your practice questions, different things. But let's go back in your book and let's make sure we understand a couple of things. So, what exactly does our book specify the functions of the kidneys? The main function of the kidneys is to regulate the volume, okay, composition, and pH of body fluids. In the process, okay, once again, the volume, the composition, and the pH of body fluids. Now, the kidneys remove metabolic waste that are broken down, okay, metabolic waste from the blood and excrete them to the outside, okay. So the urinary system has to take the waste, pull it out of the blood. It's been broken down, it's gone through the digestive system. The waste are in the blood. We've got to pull the waste out of the blood and then remove them from the body totally. Okay? So it says these wastes might include nitrogenous waste and sulfur-containing products of protein metabolism. So nitrogenous waste means that they're tied to a nitrogen base. Okay? And sulfur-containing products of protein metabolism, meaning that when we ordinarily break down protein, we produce a lot of these wastes. A lot of the normal body functions that we have in making proteins and making, well, when we break down carbohydrates, we break down proteins, we use a certain part and then we have a waste that's got to be removed. The kidneys also help control the rate of red blood cell formation, okay? So that's a big thing too. They control the rate of red blood cell formation. So the kidneys actually dissolve the red blood cells that, you know, we replace our blood cells every so often. We will learn that back in the unit on blood. And the kidneys actually filter out the old blood cells. And so they dictate when we make new red blood cells based on how many old red blood cells are being recycled. And it says by secreting the hormone, and we talked about this earlier, okay, erythropoietin, okay, it tells it to produce more red blood cells. Regulating blood pressure by secreting the enzyme renin, okay. Now, blood pressure, and we have all these chemicals in the body, so whenever something happens, it triggers a chemical. Renin, okay, which once again, let's think about that word renin. Okay, what word does that sound close to? And there's a reason for that. Renin and renal almost sound the same because they're both adjustments from the kidneys. Okay, so they regulate by secreting this enzyme. We can also regulate our blood pressure, higher or lower. All right, so isn't this amazing? And regulate absorption of calcium ions by activating vitamin D. Okay, so we learned that back in chapter 18. So we can make calcium absorb. We can raise and lower our blood pressure. We can determine how many new red blood cells we're producing. We can remove waste. All of that where? In the kidneys. Wow, that's amazing. That's amazing. One of the things that everybody's probably heard about, and it's kind of, we talk about a lot, you can live with one kidney. You can't live without any kidneys. You can live with one kidney, but you got to realize that in order to live with one kidney, okay, and everybody's like, well, I'm going to donate my kidney, and that's a very, very noble thing to do. But you have to realize that if you're going to live with one kidney, you're going to have to realize that you have half of the production of these functions. So if you only have one kidney, you actually have to be really, you have to watch what you eat, what you absorb. You have to watch, somebody that's bleeding, that has internal bleeding with one kidney, it's a whole different deal. Produce red blood cells much slower. So one kidney is possible, but I don't want to make it sound like that everything just operates normal if you have one kidney. So kidneys are critical. I give you a lot of stuff, and you don't need to. Now I tell you, you don't need to write all that down, but those things are going to be covered in a lot of the notes we're going to have. So I'm gonna kind of give you a break. We're kind of right in the middle of the class. I'm gonna give you a lot of the testing information, okay, and then we're going to come back and take a look at it some more. So I did this on the last test. I don't know if it helped you or made it more complicated or easier, but I'm going to kind of give you possible test material. So from here on out, I would take some pretty good notes. We'll come back and kind of tie all this in. Now why do I feel pretty good about giving you this stuff? Because this has been hand selected. This is the stuff that you have to know for the for like North Central accreditation, college classes. It's kind of like we would like to say you need to know everything in this book. And we would like to say, okay, anybody that's taking this college class is going to know everything from this book, but we got to narrow it down a little bit. So they figure if you know these, then you know the other things too. So here we go. Take some pretty good notes. All right. So let's talk about the kidneys. Okay. The kidneys are positioned. Okay. Now listen to this word. This is a kind of a new word. Retro, R-E-T-R-O, and then peritonally. Okay. So let me spell it. R-E-T-R-O. P-E-R-I-T-O-N-E-A-L-L-Y, okay? Retroperitoneally. So what that means is that they're located exactly apart from each other. That they're isomers. Isomers mean that it's a mirror image, okay? If you were to take a mirror and hold it to your face, you would find that our bodies are completely symmetric. Completely symmetric. We could hold our arms out like this and draw a line directly down our body and put a mirror right there, and it would almost look like our whole body's there. We're completely symmetric organisms. And so the kidneys are directly across from each other, okay? The exact same height, not one kidney's higher than the other. There's a reason for that, okay? Well, what else about the kidneys? Well, they're padded by a layer of fat. And that's really critical. So, sometimes we're eating fat and we're like, wow, I don't want any fat or whatever. But no, the kidneys have to have fat around them. They have to be padded for three different reasons. First of all, it's protection. We literally get hit, and usually it's from the back. The kidneys, oftentimes you get hit in the back and it hurts the kidneys. But the kidneys are so fragile inside, okay? They have the nephrons inside. They're so fragile inside that they're padded by a layer of fat. The layer of fat also protects the circulatory system on the outside of the kidneys, and it also causes a good temperature and pH balance, so that the layer of fat that's around the kidneys keep the pH and the temperature and everything to where the kidneys are separated from the rest of the body. So The kidneys are padded by a layer of fat, and then inside the kidneys there's a hollow chamber called the renal sinus. Okay. Now, anytime you hear the word sinus, it means a hole or an opening or a cavity. Okay. So we say a renal sinus, that we know renal means kidney and sinus means an opening. Okay. So inside the kidneys there's a hollow chamber called the renal sinus, and in that chamber is where we're going to filter out and clean the blood out. Okay. Now, the granular appearance of the renal cortex is due to, okay, so if we were to look at, and once again, if you've got the 13th edition and you go to page 773, you're going to see all the blood vessels in there. And so when we look at the kidneys, they're not totally 100% smooth like you might think, okay, and they have smooth muscle, but they're actually granular appearance. And what it's due to is the random distribution of nephrons in that area. So we have these nephrons, and these nephrons are actually the little bitty filters. So it's kind of like, you're filtering something out, whether it's the oil in your car, or whether it's you're straining something out in your kitchen. You have one filter. What do the kidneys have? The kidneys have hundreds and hundreds of little filters called nephrons. Okay. Well, those nephrons then are all packed in the area, and in the renal cortex, it gives it a granular structure because there's so many nephrons in that area. Okay, so it's a random distribution of nephrons in this area. Now, let's talk about the kidneys. The kidneys help control the rate of red blood cell production. Okay, so how do they do that? They pick up the blood cells that are being recycled, that are dead, and they say, okay, we need to make more new red blood cells. All right. The kidneys help to regulate blood pressure. All right, so kidneys regulate blood pressure, and what else do the kidneys do? The kidneys regulate the composition, volume, and pH of body fluids. So I told you earlier that I kind of gave you an overall statement earlier, and we're breaking that down into different questions. But what do the kidneys do? They help control the rate of red blood cell production. They help to regulate blood pressure, and the kidneys regulate the composition, volume, and pH of body fluids. All right. Now then, let's see where we want to go here. Let's stop right there, and we'll pick you up with the next video.